Yeah, so we'll start. So this is first paper of fourth semester, that is MAT 401. It is numerical methods. So title of this paper is numerical method. This is first paper of fourth semester. Actually, there are five chapters. So first we will see just revise syllabus of this paper. So there are five chapters. So book for this paper is Introductory Methods of Numerical Methods by S.S. Shastri. So from this book, total five chapters are there, not complete, but some. So chapter three is complete. Chapter two, it is just one fourth part is there. Chapter four, it is again one fourth part of chapter four. Chapter six, it may be half part, and chapter seven, it is just introductory part of this book is there in our syllabus. So let us see what is the actual syllabus of this course. Solution of algebraic and transcendental equation, that is chapter first. So this is chapter number one, that is solution of algebraic and transcendental equation. So in that first we will see what is algebraic equation and what is transcendental equation. So in that we will see introduction to algebraic and transcendental equation, and then we will see the methods for solution of algebraic and transcendental equation. So what is algebraic and what is transcendental equation? So algebraic, so this is a different thing, and transcendental, so it is again a different thing, and combinedly. So we'll solve algebraic and transcendental equation by numeric techniques. So these are not analytical or usual methods, but we will see numerical methods to solve algebraic and transcendental equation. So in short, there are only three methods, that is bisection method, method of false position, and Newton-Raphson method. Generalized Newton's method, it is just, yes, modification of Newton-Raphson method. So just three methods are there. So first, in first chapter, we will solve algebraic and transcendental equation by three methods. First method, that is method one, that is bisection method. So the syllabus is already I shared in WhatsApp group and Google Classroom. So there is no need to write. So directly you can download, or you can go in university website. So you can find the syllabus. So you can download it. We'll just discuss here. So in first chapter, we'll see three methods. That is first method, bisection method. Second method, that is false position method, or it is also called regular false method. That is false position method. And third method, that is Newton-Raphson method. So in detail, we'll see Raphson method. So these three methods are there in first chapter. Second chapter, that is interpolation. So this is totally different chapter. So in this chapter, we'll see definition of interpolation. So in that we'll see extrapolation and interpolation. So what is interpolation and what is extrapolation? So we'll see its definition in short. So after that, so there is a definition of finite difference. In that there are so many finite differences. That is forward difference, backward difference, shifting operator, and Newton's divided difference is there. So we'll see finite differences, for example, forward differences, backward differences, central differences. Actually, central difference is not there. So by mistake it is there. And symbolic relation and separation symbols of differences of polynomial. So it is there. And after that, so it is introductory part. So till here, it is just theoretical part. So after that, So we'll see Newton's formula for interpolation. So in that we'll see Newton's forward difference interpolation formula and Newton's backward difference interpolation formula. And then we'll see interpolation with equally spaced points and interpolation with unequally spaced points. So for interpolation with equally spaced points, there is Newton's forward difference interpolation formula and Newton's backward difference interpolation formula. And for interpolation with unequally spaced points, for that there is Lagrange's interpolation formula, Hermite's interpolation formula, and Newton's divided difference interpolation formula. So this chapter number 2, we can divide this chapter in two parts. See, so chapter 2 can be divided. See, it can be divided in two parts. Part 1, that is interpolation with equally spaced points, and part 2, that is interpolation with unequally spaced points. So this is chapter number 2. So this main chapter of this course, it contains approximately 40 or 35 to 40% syllabus of this course. So this main chapter. So we'll see afterwards. Then chapter number 3, that is curve fitting and approximations. So what is curve fitting? So there is least square method for curve fitting. So it is called least square curve fitting procedures. So we'll see its introduction. So in introduction, we'll see what is interpolation and what is curve fitting. So interpolation and curve fitting, these are two different techniques. So we'll see in introduction. So then we'll say least squares curve fitting procedures. First, that is fitting straight line, then fitting non-linear curve fitting. It means that is fitting of second degree polynomial and so on. Then we'll see approximation of functions. So in that we'll see Chebyshev polynomial. So we'll see definition of Chebyshev polynomial, and then there are some relations between Chebyshev polynomials. Then we'll see economization of power series. So again, this chapter you can divide the chapter into parts. First part, that is curve fitting. Curve fitting means, so that is least square curve fitting techniques or method for fitting straight line and nonlinear curve fittings. And after first part, second part will be approximation of functions. Then Chebyshev polynomial and economization of power series will be second part of this chapter. So this is chapter number 3, that is curve fitting and approximations. Curve fitting is different thing and approximation is a different thing. Then chapter number 4, that is solution of linear system of equation. So this chapter is again important. So I can start the chapters which are most important. So yeah, so I'm giving it as 2 star. I'm giving it as 4 star. So according to weightage of syllabus, I'm giving it as yeah, 2 star. And again, I'm giving it as 3 star. See, that is chapter number 4, solution of linear system of equations. So we'll solve here system of linear equations, three linear equations in 3 variables. So we'll solve the system. So to solve the system, we'll see here two types of methods, that is direct methods and indirect methods, or these are called iterative methods. So indirect methods are iterative methods. So in the chapter, we'll see two types of method to solve system of linear equations. So solution of linear equations, system of linear equations. So there are direct methods, and direct methods are, so I'm writing here, yeah, see, so there are direct methods. So A you can write, that is direct methods, and indirect methods. So first, that is Gaussian elimination method or Gauss elimination method. So in that, first, that is Gauss elimination method. Second, that is method of factorization. And third, also there is Jordan method. So these three are direct methods, and in B part we'll see indirect methods. Indirect methods. So in indirect methods we'll see, so Gauss-Seidel iterative method and second Jacobi's method. So first, that is Gauss-Seidel iterative method, and second, that is Jacobi's method. So in this chapter we'll solve system of linear equations. So using direct methods and indirect methods, and after that we'll see eigenvalue problem. So in that there is Householder's method, then eigenvalues of symmetric tridiagonal matrix, and last that is QR method. So there are different methods in the chapter to solve system of linear equations. Chapter number 5, that is numerical solution of ordinary differential equations. So first we will see what is ordinary differential equation. So in that we'll see IVP, that is initial value problem. So we'll see introduction for that, and after that we'll solve ordinary differential equation using numerical techniques. And for that there are different methods. So first, that is Taylor series method. So in chapter 5, so we'll solve ordinary differential equation by numerical techniques. So there are different methods. So method 1, that is Taylor series method. Then second, that is Picard's method, or it is also called Picard's successive approximation. Then third method, that is Euler's method. And fourth method, that is Runge-Kutta method. Runge-Kutta second order and Runge-Kutta fourth order method. Runge-Kutta methods. Actually, these are methods, means we'll see two methods of Runge-Kutta, that is Runge-Kutta second order and Runge-Kutta fourth order method. So this is syllabus of this course. So it contains total 5 chapters, and if we see consider the weightage of chapters, so I will give again 2 star for this chapter. So most important chapters are interpolation, that is second chapter, and fourth chapter, that is solution of linear system of equations. And yeah, so curve fitting and approximation. So I can give single star or 2 stars. 2 star because of the second part, that is Chebyshev polynomial and approximation of functions. So this is about syllabus of numerical methods, that is MAT-401. So we'll continue first chapter, that is solution of algebraic and transcendental equations. So what is algebraic equation and what is transcendental equation? So definition of algebraic equation. This algebraic equation. An equation which contains only polynomials is called algebraic equation. And what is transcendental equation? The equation which is not algebraic equation is called transcendental equation. So definition of transcendental equation: an equation which is not an algebraic equation is called transcendental equation. It means that, see, the equation which is not polynomial equation. So what is transcendental equation? It may contain a trigonometric function, or it may contain exponential function, or it may contain logarithmic function, or like this. It means that. So what is example of algebraic equation? That is polynomial equation. That is x square plus 5 equal to 0, or you can take x cube plus 2x plus 5 that is equal to 0, or likewise. And what are the examples of transcendental equations? So you can take x into e raised to x plus 5x plus 10x equal to 0. So that will be transcendental equation. It means that an equation which contains these terms, that is e raised to x sin x, means, sorry, an equation which contains exponential terms, exponential or trigonometric or logarithmic terms, is called transcendental equation. So you can take sin x into log x equal to 0. It is again example of transcendental equation, or just you can take x into log x equal to 0. It will be another example of transcendental equation. So this is the difference between algebraic equation and transcendental equation. So these are two different types of equation. So in this chapter, that is chapter number first, we will see what is chapter number 1. See, chapter 1, that is solution of algebraic and transcendental equation. So this is title of the chapter. So in that we will see total 3 methods. So in the chapter, so first you can read it as 1.1, that is bisection method. 1.2, that is false position method. 1.3, that is Newton-Raphson method. So first, that is bisection method. So we'll continue. So what is bisection method? So in this section, we'll solve equation of the form fx equal to 0, The equation fx equal to 0 will be algebraic or transcendental according to fx. Means, so fx equal to 0, this is an equation which we have to solve. It may be algebraic equation or transcendental equation. It may be algebraic or it may be transcendental. See, that depends on this fx. If fx is just polynomial, then it will be algebraic equation, and if fx contains either exponential term or trigonometric term or logarithmic term, so it will be transcendental equation. So if fx is purely polynomial in x or contains some other functions such as a trigonometric, logarithmic or exponential functions, etc. So for example, so x cube minus x plus 2 equal to 0 is an algebraic equation because fx equal to x cube minus x plus 2, which is purely polynomial, and therefore it is an algebraic equation. And sin x plus x square minus log x equal to 0 is an transcendental equation. Normally it is assumed that fx is a continuous function. It is very important. So always we will consider this fx as continuous function. So what is the root of, actually we have to solve fx equal to 0. We have to solve this equation fx equal to 0. So fx equal to 0, it may be algebraic equation or transcendental equation, that depends on this fx. So if fx is purely polynomial, then it will be algebraic equation, or if it contains, see, that is some other functions such as trigonometric or logarithmic or exponential functions, then resulting function, that is function fx equal to 0, will be transcendental equation. So we have to solve this algebraic or transcendental equation fx equal to 0. What is solution of this? Let us see. What is solution of fx equal to 0? So what is meaning of solution of fx equal to 0, or what is meaning of, see, root of fx equal to 0? So we'll call it as root. Solution of fx equal to 0, we will call it as root. And how to find that root, or finding root of fx equal to 0 is called, so method of solution of fx equal to 0. So see, what is root? If f of c equal to 0 for